to solve these simultaneous equations using a matrix method. Okay, and first thing we do is we set up our matrix equation. So we will take the coefficients of x and y and put them in one matrix. So we are taking out the 4 here, taking out the 1 from in front of the y here. If you don't see a number, then the number is 1. Taking out the 3 from in front of the x, taking out the 2 from in front of the y here. Okay, now we have our matrix of our unknowns x and y. And then we have 1 and 2. This 1 comes here, and this 2 come here. So we have our matrix equation. Step 2 is to write the matrix equation in this form. Xy is equal to 4, 1, 3, 2 inverse times 1, 2. So we need to go and find the inverse of this matrix. Okay, so let's do that. We are saying, let's call the matrix A. Okay, so remember A inverse is equal to 1 over the determinant of A times the adjoint of A, ADJ for short, and we have to find the determinant of matrix A. We will call it matrix A. Okay, this is matrix A here, capital A. Sometimes this other matrix is called little x. Sometimes the last matrix is called little b. Okay, so let's find the determinant of A. We have to multiply this way, 4 times 2. And we have to subtract, multiply this way, 3 times 1. And that gives us 4 2s are 8, take away 3 by 1 is 3, and that gives us 5. Okay, so we have our determinant. Let's find our adjoint now. Adjoint A. And remember, we have to do some switching around. So we switch the 4 and the 2 around. We interchange their positions. So the 2 will be here and the 4 will be here. Afterwards, we change the signs. So this would be negative, negative here. Okay. We change the signs along this line. So we'll have negative 1, negative 3. And that's our adjoint. So the inverse, the matrix with coefficients, is equal to 1 over the determinant, which is 5, multiplied by adjoint of A, 2, negative 1, negative 3, and 4. We multiply each number on the inside by 1 over 5, and that will give 2 over 5, negative 1 over 5, negative 3 over 5, and 4 over 5. Okay, So we have our inverse. Let's get our answer now. We want to find xy. We are coming back to this equation here now. Alright, we are substituting here. Okay, this value must come here. Okay, so let's do that as equal to 2 over 5 minus 1 over 5 minus 3 over 5 and 4 over 5 times by 1 over 1, 2. Let's do our multiplication row by column. Alright, so this row times this column. Okay, so let's see what happens. 2/5 times 1 plus negative 1 over 5 times 2. Okay, negative 1 over 5 times 2. And negative 3 over 5 times 1. Now we multiply this row by this column to get our value here. Okay. Right, so we're plusing 4/5 times 2. Let's work that out. 2/5 times 1 is 2/5. Have 2 over 5 here. Negative 1/5 times 2 is negative minus 2/5, right? Remember, plus minus is a minus. Negative 3/5 times 1 is negative 3/5. Alright, and then we have to add that to 4/5 times 2. 2 4s are 8. We get 8 over 5. Okay, this is 8 over 5. Make this visible to you. Alright. So 8 over 5. Good. Good. Now we work this out. 2/5 take away 2/5 is 0. Negative 3/5 plus 8 over 5. 8 take away 3 is 5 over 5. And we get 0 on top. 5 into 5 is 1. Okay, remember we can cancel here. Let's say 5 into 5 is 1. 5 into 5, 1, which gives us 1. So we have our answers, x and y. Okay. Final answers are x equals 0 and y equals 1. Okay. If we substitute 0 into any equation for x, we'll have 4 times 0 is 0 plus y, which is 1, and we will get back 1. Okay. If we substitute x equals 0 into the second equation, 3 times 0 is 0 plus 2 times 1 will give us 2. Okay, so our answers are correct, and this is how we use matrices to solve simultaneous equations. Thanks for watching.